Well, Assalamu alaikum, my dear students. The third step of this lecture or this delivery, which is concerned with the physiology of the smooth muscle. Yes, I have been describing its structure, its types, and the excitation, contraction, coupling, its neuromuscular junction, and its various differences with the skeletal muscles, and particularly it has got a plateau. Well, these are the steps of crossing bridge cycling. The crossing bridge cycling, that is the basis of the contractility. These are the myosin and actin filaments which glide and slide over each other by the power strokes, because the cross bridges and the heads which are springing out from the myosin filaments, that causes the gliding and sliding movements, and power stroke which causes the actin filaments movement upon the myosin. As a result of that, in the case of a sarcomere, which is a functional unit of the skeletal muscle, you look that by these gliding and sliding movements, what happens? The Z lines approximate each other. But in the case of a smooth muscle, the dense bodies are the counterparts of the Z lines. So they approximate each other. The same power stroke, formation of an actin myosin ADP phosphate complex, conformational change in myosin head. Well, whenever there is a ADP phosphate complex, this causes the conformational change in the myosin head. And you must be knowing, myosin head has got the ATPase activity. Flex towards arm, generate mechanical force, which is known as a power stroke. Actin slide over myosin and causes contraction. Dense bodies are same as Z line. Relaxation of a smooth muscle, calcium pump removes calcium from ICF to the ECF. चूंकि मैं आपको बता चुका हूं, the calcium in the case of a smooth muscle that comes from two sources. One is from the ECF, extracellular fluid, and other is from inside, that is the sarcoplasmic reticulum. When the contraction has taken place, now this calcium will go towards the original site. That which came from the ECF, that will go to the ECF side. Which came from the sarcoplasmic reticulum, that will enter into the sarcoplasmic reticulum. And this is also an active phenomena. This is active phenomena. Calcium pump removes calcium from ICF to ECF, reverse all stages except phosphorylation of the myosin. Phosphorylation is not changed. You're looking here. At rest, myosin act. Myosin cannot bind to actin in absence of a light chain phosphorylation. Yes, you're looking here. There is a no binding. Then here the kinases come. It has got the phosphorylation over here. Cycling ATP has been changed to the ADP. The phosphate, ADP are attached. It causes the activation. What happens? The myosin rapidly dissociates from actin upon binding ATP during each cycle. Initial rise in the muscle tension. That causes initial rise. Latch bridges. The phosphorylated myosin dissociates from actin very slowly, producing slow bridge cycling, maintain tension, tonic contraction. See, this is here. This is the latch bridges. Relaxed smooth muscle cell, dense bodies, bundle of a thick and thin, one relaxed contractile unit. What do you mean by the relaxed? It means the dense bodies are now away from each other. Now away from each other. It should be very much clear to you, while thin filament and a thick filament in the case of a smooth muscle. Characteristic of excitability and contractility, slow excitation, contraction coupling, plasticity. Latch phenomenon is a characteristic of a smooth muscle. Mostly asked in the viva, what's the latch phenomenon? Marked shortening of smooth muscle during contraction. Energy required to sustain smooth muscle contraction. Slow excitation, contraction coupling. Smooth muscle contraction starts after 200 millisecond after spike. Peak of contraction, this is after 500 millisecond. Plasticity, can readjust its resting length. Thus, it not follows length tension relationship that is valid for saturated of muscle. So length tension relationship curve is jagged line. You're looking here. Length tension curve. Tension is there. Tension does not come to a baseline. It is there. Passive tension is there. Tension, resting length. Tension doesn't come to the baseline. This is the plasticity. Then you're looking here. Latch phenomenon, mechanism by which smooth muscle maintains high tension without actively contracting. यानी contract भी नहीं कर रहा muscle, लेकिन tension उसमें मौजूद है. This is known as a latch phenomenon. And you're looking here. Allows long-term maintenance of tone. This is the cause. This is the basis of a tone. कि all those viscera, gastrointestinal tract है, basically it's a potential. ये हमेशा कॉन्ट्रैक्ट रहेगा. वेसल्स हैं, ये भी नैरो रहेंगी. दे आर नॉट दैट मच पेटेंट. क्यों? इट इज बिकॉज ऑफ द मेंटेनेंस ऑफ द टोन, एंड दिस इज नोन एज अ लैच फिनोमिना. सो मसल कैन नॉट जनरेट एक्टिव टेंशन बट रेजिस्ट पैसिव स्ट्रेचिंग. दैट इज द लैच फिनोमिना. एट रेस्ट यू आर लुकिंग हियर. इट्स नॉट गोइंग टू कम बैक. द टेंशन इज रिमेनिंग, टोन इज रिमेनिंग. These are the potential. यानी vessels, GIT tract, ureter हमेशा contract रहते हैं. कब खुलते हैं? When some things come, when some solid things come, marginic, the stretching is there. So this is known as a latch phenomena. The tension with the least expenditure of the energy is the latch phenomena, characteristic of the smooth muscle. Since smooth muscle found mainly in hollow viscera that should resist stretching. वो stretch को resist करते हैं. Cause both myosin kinase and myosin phosphatase enzyme strongly activated. Cycling frequency of myosin head and velocity of contraction increases. As this activation and cycling frequency decreases, lower activation of enzymes causes myosin head to remain attached to the actin for longer time with less energy expenditure as ATP is required for detachment. यहाँ पर लैच फिनोमिना है कि as this activation and cycling frequency decreases, lower activation of enzymes causes myosin head to remain attached to the actin for longer time with less energy expenditure as ATP is required for detachment. ATP require होती है detachment के लिए. अब यहाँ पर ATP नहीं है और ये अटैच्ड रहेगा. इसका अटैच रहना इस बात की दलील है कि ये कॉन्ट्रैक्टेड स्टेज में रहेगा. इसकी कॉन्ट्रैक्टिलिटी रहेगी, इसकी टोनिसिटी रहेगी, विच इज नोन एज अ लैच फिनोमेना. द इंक्रीज टोन ऑफ द स्मूथ मसल डिस्पाइट द लेस एक्सपेंडिचर ऑफ द ATP is known as a latch phenomena. It's a character of the smooth muscle. Marked shortening of smooth muscle during contraction. Yes, a smooth muscle can contract more than 2 to 3 its stretched length, while skeletal muscle contract up to 1/3. यानी जो skeletal muscle है वो अपनी initial length की 1/3 तक contract कर जाता है, जबकि वो 2/3 तक उसकी shortening जो है वो कम होती है, इसकी shortening जो है वो ज़्यादा होती है. Marked shortening of smooth muscle during contraction, उसकी marked shortening है और skeletal muscle की जो है वो less shortening है. Smooth muscle can contract more than 2/3 of its stretch length. जब आपने इसको खींचा उसका 2/3 ये जो है इसकी marked shortening होगी. Skeletal muscle की जो है वो 1/3 shortening है. This allows viscera to change diameter from large to almost zero. देखें, इसी की वजह है कि उनके जो डायमीटर है वो बहुत ज़्यादा बढ़ सकते हैं और फिर कम भी. दिस इज ऑल्सो नोन एज अ कंप्लायंस. ये कंप्लायंस भी है. फिर इसको नोट कीजिएगा कि मार्क्ड शॉर्टनिंग ऑफ स्मूथ मसल ड्यूरिंग कॉन्ट्रैक्शन. कॉन्ट्रैक्शन में स्मूथ मसल की मार्क्ड कॉन्ट्रैक्शन होती है, शॉर्टनिंग हो जाती है.